Hello everyone, how are you all? Must be doing fine, right? So, today we'll be starting our new chapter of 12th class from NCERT book. That is, yeah, a bit complicated one, but not that. It's inverse trigonometric functions. You must have studied trigonometric functions in 10th standard and then in 11th standard, but inverse trigonometric functions, these are a bit similar as well as a bit different as well. So very basic trigonometric function, firstly, that is sine x. The inverse of sine x is represented as sine inverse x, and these kind of inverse is driven through the concept of functions, that is one onto functions and bijective functions, which we are surely not going to discuss in this video, as the videos will be separate videos of the chapter relations and functions, right? So yeah, for time being, just keep in mind that the inverse of sine x is represented as sine inverse x, and that of cos x is represented as cos inverse x. And similarly, all of the trigonometric functions inverse can be represented by simply putting -1 in the exponent of the trigonometric function, right? In the very first exercise, they will be talking about the principal value of these functions. Now firstly, let's discuss a bit about the graphs of inverse trigonometric functions. Now, if someone of you is familiar with the concept of sine wave, right? So this was the sine wave, if I'm not wrong, because sine 0 and its range is from 1 to -1, 1 and -1. So it starts from 0, then it goes to pi by 2, then comes to pi, then again 3 pi by 2, and then so on, like this, right? So this is the value of 0, because sine 0 is 0 over here, and sine pi by 2 is 1, then pi by 2 plus pi by 2, that is sine pi is again 0, then pi plus pi by 2, that is 3 pi by 2, 3 pi by 2 plus pi by 2, that is 2 pi. Yeah, so this is sine wave, right? This was the y-axis and this is the x-axis. Now if we draw the graph of sine inverse x, what will you get? You will get a similar graph, like absolutely same graph, but the x's will be interchanged. Like this was the x-axis, it will remain x-axis, and your function will be drawn along with y-axis only, like this, and up to so on. This is the basic difference in the graphical representation of trigonometric functions and inverse trigonometric functions. Here it will be again 0 and it's -1, and on the right hand side you will get +1. So corresponding to 1, it was pi by 2, it's 0, then it will be pi by 2, then it will be pi, and then it will be 3 pi by 2, and similarly the graph will go on, but the only x's are interchanged. The same is the case with cos x and all the other inverse trigonometric functions, right? So firstly, sometimes in exam you can be asked that draw the graph of this function, so that's why this information is very important for you, right? So these were the graphical representations of trigonometric functions as well as inverse trigonometric functions. I have drawn the graph of trigonometric function to just make it clear the graph of inverse trigonometric functions, right? So let's move to the domain and range of inverse trigonometric functions, because first exercise is mainly based on that. Okay, I will explain you the concept of domain and range with the help of domain and range of sine function. Now simply, the domain of sine function is set of all real numbers. Now what is a domain? Domain is the value that the independent variable can select. Okay, like for example sine x, the x can select what kind of values, that is what is domain. Or in simple words, the values that can be taken on by x or any of the variable which is involved in the function is known as its domain. And what is the range? Range is the resulting value when we put any value from domain into the function, and the value that we get as a result, it's known as range. The set of all of those values is known as a range of that function. Okay, now the domain of sine function is the set of all real numbers, that it can take up any value from the set of real numbers, and the range of sine function is given by a closed interval -1 and 1. Now to get the domain and range of course the inverse trigonometric inverse sine function, we will restrict the domain of sine function from the set of real numbers to only -π/2 and π/2. Okay, then the range which is corresponding to this, it will be known as the range of the inverse value function. Okay, so these were the things that were mainly related to the simple function. I told you that it's of inverse function, but it's of simple sine function. All right, that was my bad. And to find the domain and range of sine inverse, we consider the domain of sine inverse function as closed interval -1 and 1, and the range of the sine inverse function as -π/2 to π/2, the closed interval. Okay, now this range is also known as the principal value branch. Okay, because this concept is going to be used in the first examples of first exercise, principal value branch, right? It means the range with the branch of this is known as principal value branch, and the similar is the case with all the other trigonometric functions, right? So the domain of sine inverse function is -1 and 1, and the range of sine inverse function is -π/2 to π/2. Now if we want to write the domain and range of cos inverse, the domain is same, because the range of cos, only simple cos function, was also the set of all real numbers. That's why the domain of cos inverse is same as that of sine inverse, and the range will be 0 to pi, closed interval. These are the domain and range of sine inverse and cos inverse function. Similarly, you can write and you can learn the domains and ranges of cosecant, because this is the cosecant, -1 to 1, and then -π/2 to π/2. Okay, so these kind of domains and ranges that you can learn from your book. Now sometimes in exams you can be asked a question that simply write the domain of sine inverse function, write the range of sine inverse function. This is why you literally have to learn these values, that this is its domain and this is its range. Okay, and graphical representation can also be there in your exam. So there are only two examples which are related with the principal value of some of the inverse trigonometric functions. So let's do those examples and let's see that what is involved in this chapter. Okay, this is very first example of our first exercise of inverse trigonometric functions. In this we have to find the principal value of sine inverse 1 by under root 2. We'll be going step by step to solve these kind of sums, because there are only two examples, so we have to make the concepts clear in order to attempt more and more sums correctly. Now sine inverse 1 by 2. Firstly, let y is equals to the given function, that is sine inverse 1 by under root 2. Now you can find out the value of sine y, because here it's sine inverse and here we can write it as sine of y, which will be equal to 1 by root 2. Now what do you mean by the principal value of this function? Whenever you go to attempt these kind of sums, just keep in mind the principal value branch of the given function. Now the sine inverse principal value branch is -π/2 to π/2, as we have literally discussed that the range of sine inverse function is -π/2 to π/2. So this is our principal value branch. It means the resulting value of y should be lying in this interval. Okay, only then it will be considered as the principal value. Now we know that 1 by root 2 can be written as sine π/4. So we can write sine y is equals to sine of π/4, or you can say that y is equals to π/4. Now you can clearly see π/4, it means 45 degree, and π/2 is 90 degree. So -90 to 90. It means our value is lying in the given principal value branch, correct? So which means that the given value that we have just got, it is the principal value. Okay, so principal value can be found like this only. Now it is a bit easy because you have directly got the principal value, because pi by 4 was lying in the interval of principal value branch, but not all times it will happen like this. This is our second and concluding example of the first exercise. In this, we have to find the principal value of cot inverse 1 upon under root 3. Now, before actually proceeding, just keep in mind the range of the given inverse trigonometric function, which is 0 to pi in the case of cot inverse. Okay, that is why I'm saying it repeatedly, that you have to learn the ranges and domains, especially the ranges, to attempt these kind of sums in your mind before proceeding. Okay, so the range is 0 to pi. Now we'll follow the same steps that we have followed in the previous example, that is, let y is equals to cot inverse 1 upon root 3. Right, now we will find the value of cot y, which will be equal to 1 upon root 3. Okay, so it's actually minus 1 upon root 3 in the statement, so I'm sorry for that. Okay, cot y is equals to minus 1 upon root 3. Now we know that cot of pi by 3 is 1 upon root 3. Yeah, so we can easily write that y is equals to minus of pi by 3, correct? But the thing is, this is not our principal value. Why it's not our principal value? Because it's not lying in the interval of principal value branch. Our principal value must be greater than 0 and less than pi, and this is minus pi by 3, which is less than 0. That is why we have to modify it a bit, and only then we will be able to find the principal value. Now what will we do? Just remind yourself the concept of quadrants that you have learned, and in the first quadrant all are positive, and sine and cosecant are positive in the second quadrant, tan and cot are in the third quadrant, and cos and secant are in the fourth quadrant, right? So yeah, this concept I guess that you have learned in 11th class complex number sums in the polar form, and when you have to transform into some other form, right? So here this is 0, and then it's 90, then 180, then 270, then it's 90 plus theta and 180 minus theta, that is 90 plus theta and pi minus theta lies in the second quadrant, and similarly pi plus theta and 270 minus theta lie in the third quadrant, and similarly, and so on. So let's don't go into this concept deeply, but if you are unaware of this concept, you can DM me personally on my Instagram, which is given in the description. The link of my ID is given, and you can also use comment section to get my assistance. Okay, so now why I have just outlined this concept, because we are going to use it over here. We can write cot y is equals to minus of cot pi by 3, correct? Now we know that if our degree, our angle is 90 or 270, the t ratio changes, but if it's pi and 360, the t ratio does not change. This is also the same concept. We can write it as cot of pi minus pi by 3. Why so? It becomes pi minus theta, which is lying in the second quadrant. As I have told you, in the second quadrant only sine and cosecant are positive, which means the cot is negative in the second quadrant. So yes, when we will get the negative sign, negative will be cancelled and you will get the positive sign. Or simply you can say that we have just written this thing as this because it's lying in the second quadrant. Now pi minus pi by 3, that is 3 pi minus pi, that is 2 pi by 3. Cot of y is equals to 2 pi by 3, and also it's 180 degree, that is pi. That is why cot cannot be changed into tan, but if it would have 90 or 270, then cot would have changed to tan. Okay, so this is the basic concept that most of the students learn in 11th class. Still, if you have any problem in this step, just feel free to ask me. Now in this way y can be turned out to be 2 pi upon 3. Now the value of y must be in between 0 to pi. So it's, I guess, 120 degree, right? So it means we have found our principal value of cot inverse minus 1 upon root 3. Yeah, in the first example it was pretty much easy because we got the principal value directly, but in this example we have to do a little bit modifications, right, just to get the principal value correctly. In this way you can get the principal value of any inverse trigonometric function which is given. And so with this, our first exercise of inverse trigonometric functions is completed and only one exercise is left. In the next exercise there will be some identities. In the similar way that you have learnt identities of simple trigonometric functions, you will get to know the identities involving inverse trigonometric functions. So till then, bye bye and keep practicing. Happy practicing, and just don't forget to press the subscribe button before leaving my channel. It will be very grateful of you guys, and thanks for watching. Just keep practicing and keep practicing. Feel free to DM me or feel free to ask me any question in the comment section, right? I'll be waiting for your comments down there. So till the next video, bye bye, thanks for watching, best of luck.